Hello everyone, in this video we are going to talk about modeling with differentiation. Firstly, let's quickly recap. dy over dx, that is the first derivative we also call the gradient, which means the rate of change of y with respect to x. And the second derivative means the rate of change of the gradient. Now let's move on to see an example question. Well, the question said that a large tank in the shape of a cuboid is to be made from 54 meters squared of sheet metal. So we can sketch a cuboid. The tank has a horizontal base and no top, which means we don't have this part. So no top. It also said that the height of the tank is x meters. So we have the head, that is x meters. And the question also mentioned that the two opposite vertical faces are squares. So we have two vertical faces, that is this one and this one. They are squares, which means the width of the tank is also x. Right? Now the part A said that you need to show that the volume of the tank is given by V equals to 18x minus 2 over 3x cubed. Recall that when you want to find the volume of the cuboid, what you need to do is you need to times length, width, and height together. But in this question, we don't know the length of the tank. So what we can do, we can label the length of the tank be y. Let the length of the tank be y. So we have y over here, right? And then you need to find the relationship between y and x, since the final answer is only include the x, right? Now we know that the total shape of the tank is 54 meters squared. And you remember that there is no top. So we need to calculate the total area of this tank. Let's say total area of tank, that is no top, without top, let's say BS. So S equals to, firstly let us calculate the two vertical faces. So we have two squares, that is 2 times x squared. And then we need to plus other faces. So we have 3 times xy. So that are faces over here, and the bottom one, and the backwards one. So there are 3, right? That equals to 54. Then we can find the relationship between y and x. We have 3xy equals to 54 minus 2x squared. So y equals to 54 minus 2x squared over 3x. We know that the volume of the tank is length times width times height. So we have y times x times x. that equals to x squared y. And we substitute this expression into here. We have y equals to x squared times 54 minus 2x squared over 3x. Then we rearrange that. We have x over 3 times 54 minus 2x squared equals to 18x minus 2 over 3 x cubed. So we can see we have the same expression. So we get the correct answer. Now let's move on to see the part B. Given that x can vary, use differentiation to find the maximum or minimum value of x. So from part A, we know that the expression of the y is that y equals to 18x minus 2 over 3 x cubed. Now we use the differentiation to get the gradient, that is dv over dx equals to 18 minus 2x squared. Now, when we want to find the maximum or minimum value, which means you need to find x, you need to find the value of y when dy over dx equals to 0. So if dy over dx equals to 0, we have 18 minus 2x squared equals to 0. Thus, we have 2x squared equals to 18, and x squared equals to 9. So we have two values of x, that is x equals to plus minus 3. Well, you notice that x represents the width and the height of the tank. So x must greater than 0, since the height of the tank. Then we can only have one value, that is x equals to 3. So we can get the value of v when x equals to 3, y equals to 18 times 3 minus 2 over 3 times 3 cubed. That equals to 36. So we have the value of v. And now, part C asks you to justify that the value of v you have found is a maximum. In order to identify the maximum or minimum value, what you need to do, you need to find the second derivative at first. So from part B, we have dv over dx equals to 18 minus 2x squared, which means you can get the second derivative, that is d2v over dx2 equals to minus 4x. Then we can substitute x equals to 3 into the second derivative. So if x equals to 3, d2v over dx2 equals to minus 4 times 3 equals to minus 12, that is less than 0, which means This is the local maximum. So you got that? The value of v you have found is a maximum. By the way, why do we substitute x equals to 3? Since you find the value of v when you substitute x equals to 3 in the part B. So in here, you need to define whether the value of v is a maximum or minimum when x equals to 3. Okay. If you have any question, please make a comment below the video. Thank you for watching.